once again, we're going to be talking again about mixture problems with systems of equations. This set of mixture problems are really a situation where we're adding to an existing mixture to modify it in some way. So this adds a slight additional layer of complexity, and so I do think the table you see here is going to help us to solve these types of problems. So let's look at the first example. It says a tank contains 8,000 liters of a solution that is 40% acid. How much water should be added to make a solution that is 30% acid? Okay, so for this first example, one thing we'll note is that we're adding water. Anytime you're adding water, we're going to consider that to be like 0% acid. So we're adding a 0% acid solution. We'll talk about a separate situation where we're adding 100% acid solution. So right away, let's fill in things that we know already. So we always want to kind of start with what we had initially. So we initially had 8,000, let's make that look a little clearer there, 8,000 liters of the solution, and it was 40%. We're going to write that as the decimal equivalent, so 0.4. And we can use that information to figure out what part was the acid. So if we take 0.4 times our 8,000, that would give us the part that is the acid. So 0.4 times 8,000 gives us 3,200. So we are now adding some amount of water. Well, how much water? Well, that's the question. So we don't know the amount that we're adding of water. What percent is that of acid? It's 0. So the water questions will actually turn out to be a little bit easier because what part acid are we adding? 0 times x is 0. So the last line is going to be a little bit of the sum of what we have above. So if we're talking about the volume here, the amount that we had 8,000 liters, we're adding x to it. So the new volume of our solution is going to be 8,000 plus x. Now here, we're not going to add the two rows above. We're going to think about what our goal is. Our goal is to be at 30%. So 0.3 is the percent there. So we've now left this kind of magic square that's all in bold down here. And this magic square is going to create two equations for us. Our first equation is going to come from the fact that the acid must be 3,200 plus 0. So if we just call that the acid, for A for acid, it's equal to 3,200 plus 0. Okay, that's from looking at it from these parts here. Well, we can also look at it from the percent we want times the volume that we want. So our acid is also equal to 0.3 times 8,000 plus x. Now, some of you might end up skipping the step where we write each of these equations separately, but this is our system of equations where the amount of acid, I just call it A, is equal to 3,200 plus nothing that we've added. It's also equal to 0.3 times the total volume. Ultimately, since we have two equations equal to the same thing, those equations, if we substitute, are equal to each other. And this might be the place that most of you would go towards immediately. 3,200 equals 0.3 times 8,000 plus x. It's ultimately it doesn't look like a system of equation anymore because we've already made the substitution step, but it's an equation with one variable and we can solve it. So we'll go ahead and simplify the right-hand side. So 0.3 times 8,000 is 2,400 plus 0.3x. We can subtract 2,400 from both sides, and we get 800 is equal to 0.3x. And if we divide both sides by 0.3, it's not the prettiest of numbers, but we get 2,666 and 2/3 is equal to x. So that is the number of liters of water that we need to add, and that is what we were looking for in this problem. So x here is the liters of water we need to add. So we need to add 2,666 and 2/3 liters of water. Great. Let's look at two additional examples here. So, in this next example, it says how much antifreeze should be added to 5 quarts of a 30% mixture of antifreeze to make a solution that is 50% antifreeze. Okay, let's start by recreating our table that we saw in the first one. So, draw our table here. Some of the key elements of our table is that we're going to have some amount. We're going to have our percent, and we're going to have our part. And kind of like the distance, rate, and time problem that we did earlier in other lessons, amount times percent will give us our part. Sometimes you might even see people call this quantity times percent equals part. Okay, well, we want to talk about what we initially had. We'll also want to talk about what we're adding. And lastly, we'll want to talk about kind of our end or our total solution. So from this problem, we're told that we started with 5 quarts of a 30% mixture of antifreeze, so 0.3. So 5 times 0.3 will give us 1.5 for our part of antifreeze. That's how much of the 5 quarts is antifreeze, so like 1.5 quarts antifreeze. The other 3.5 quarts, could be water or other things. So we are adding to it some amount of antifreeze, but we don't know that. So again, that is our unknown. Now, unlike when we were adding water in the last example, this time we're adding like pure antifreeze. So this is like our pure, almost acid, our pure substance. So the percent of antifreeze that we're adding is 100% in the new solution. So 100% as a decimal is just 1. So x times 1 is x. Okay, so our final solution will be the 5 quarts we started with plus however much antifreeze we have, so 5 plus x. We want our final solution to be 50% or 0.5 antifreeze. So that leaves us with this kind of magical square over here where we got two different ways to calculate it, a vertical path and a horizontal path. Both ways moving vertically down or horizontally across, we're going to multiply to get our final amount here. So I'm sorry, I'm not going to multiply both ways. We would multiply amount. So we've got a vertical pattern and a horizontal pattern. For the horizontal pattern, 5 plus x times 0.5 would give us our part. So we could say in one direction here that we could use A for antifreeze here. Going horizontally is the 0.5% we want times 5 plus x. And vertically, we want to add the initial to the amount of the new here. So the amount of antifreeze here would be 1.5 plus x. So antifreeze, acid, whatever that is, here we've got two different ways for figuring out how much of there is. So we can set them equal to each other. So 0.5 times 5 plus x is equal to 1.5 plus x. So we have a equation with one variable in it now, so now we can solve. So 0.5 times 5 is 2.5 plus 0.5x equals 1.5 plus x. All right, I'm going to go ahead and subtract 0.5x from both sides. We get 2.5 equals 1.5 plus 0.5x, running out of room. Move it back up here. All right, so 2.5 equals 1.5 plus 0.5x. Subtract 1.5 from both sides. We get 1 equals 0.5x. You could either divide by 0.5 or you could multiply by 2, however you see fit. But 2 is equal to x. So that means we need to add 2 quarts of pure antifreeze to our mixture to make it 50% antifreeze. So I'm going to have a little bit of tough time fitting a full sentence here, but I'm just going to write 2 quarts of antifreeze. Wonderful. Let's look at one more example here together. In this instance, we're not given a complete amount of acid or water. We're given a amount that is in between. So we have 12 pounds of salt water that is 10% is salt, and we're adding to it a mixture that is 3% salt. So in this situation, the 3% salt is not, it's not 100% like we were with the antifreeze, it's not 0% like we were with the water. So how many pounds of the second should be added to the first in order to get a mixture of 5% salt? So let's do some mental calculations ahead of time. If we are starting with 12 pounds that is 10% salt, and we have to get to 5%, well, 5% is closer to the 3% that we are adding. So we're going to need more of it to get there. So we're going to have, since if we have 12 pounds of the salt water here, we're going to need a lot more of the 3% to bring it down to that 5%. Okay, so let's make our table here. Okay, so we've got, again, the amount. We've got a percent, and we've got our part. So we need to find out talk about the initial amount. Think about what we are adding, and then look at our total. Okay, so we start off with 12 pounds. It is 10% or 0.1. So the amount times the percent would give us 1.2 is the salt in the salt water. The amount we're adding, we don't know that. That's what the question is. How much of the 3% solution are we adding? So X, but we know that it is 3%. So that's 0.03. So unlike before when we had 1 for 100% or we had 0 for 0% because it was water, here we actually have an amount that's in between, 0.03. All right, so if we multiply the amount by the part, we get 0.03x. Okay, so for our total, we have the 12 we had plus however much we need to add, 12 we started with plus the amount we need to add, so 12 plus x. We want our solution to be 0.05. And that leaves us with kind of our magic square that we can come about 2 ways. So if we want to call it S for salt, the salt is equal to, if we go vertically, it's 1.2 plus the 0.03x, because we're kind of adding to our total here. But going across is a multiplication pattern. So we have the salt is equal to 0.05, the concentration we wanted, times our 12 plus x. So 2 different ways to come up with how much salt should be in there. So we can substitute and say that 1.2 plus 0.03x is equal to 0.05 times 12 plus x. Great, now we have a system of equation with one variable. Well, we have an equation with one variable, so we can now solve it. So I'll clean up the right-hand side first. So 0.05 times 12 is 0.6 plus 0.05x. All right, so let's go ahead and get all our x's on one side. So let's subtract 0.03x, subtract 0.03x, and we have 1.2 equals 0.6 plus 0.02x. We can subtract 0.6 from both sides. We'll write our result up here. So we have 0.6 is equal to 0.02x. And then we can divide by 0.02, or if you recognize that we need to really multiply by 50, you can think of it that way. But either way, we get that 30 is equal to x. So we need to add 30 pounds of the 3% salt mixture. So that's 3 different examples. One where we have a percent solution that we're adding, one that we're adding 100% solution, and one we're adding a 0% solution. But these, we all have an initial amount. We're adding something to it to get our total. So when we use our tables, we want to remember that if we look horizontally in our table, that's a multiplication pattern. If we look vertically in our table, that's kind of an adding pattern. That gives us kind of this magic spot down here where there's two ways to come about it, and that creates our system of equations. And we can pretty much even jump right to those two equations being equal to each other, and then we can solve. Thanks, and check out some of the other videos we have on the different applications of systems of equations.